Hello everyone. In this video lecture, we are going to look at the effect of addition of a constraint in a linear programming problem and how to perform the sensitivity analysis there. So let's begin. And before we start, let's have a recap of what we have done so far in the previous lecture. We have already discussed the case that when we introduce some changes in the right hand side vector of the constraints, then definitely it affects the feasibility. So what to do in that case if feasibility is disturbed? We use dual simplex method to restore the feasibility or to get the new optimal solution. So let's see what is the effect of addition of a constraint. So if we have to guess that what is going to be affected, optimality or feasibility, then definitely the answer is feasibility, because we are bringing a change in the set of constraints, the system of constraints, and constraints is that component of a linear programming problem which is controlling the feasibility. Therefore, if with addition of constraints something is going to be disturbed or affected, it is feasibility and not the optimality. So let's see how to add a constraint, and we will understand this with the help of an example. So here I have taken the same example which we have discussed in the last lecture in the case of changes in right hand side. So this is the example of Toyco company which is assembling three types of toys, trains, trucks and cars using three operations, and these are the available times for the three operations, and revenues per unit of each toy is also given to us, and then assembly time per train at three operations are also given. So this data will help us to formulate the constraints. So very easily we will be able to write the problem formulation of this example. So this is LPP formulation. We have three variables which denote the number of units of toy, trains, trucks and cars. So this will be our formulation. So now let's see what additional information is given with the question. So suppose that the company is changing the design of its toys, and the change will require addition of a fourth operation. See, already three operations are there and each operation is actually being represented by one constraint. So now if they are asking to introduce a new kind of operation, so that means actually they are asking to you to introduce a constraint. So the constraint will come with the mathematical information that what should be the right hand side of the constraint. So the daily capacity of the new operation is 500 minutes. So this 500 is going to be the right hand side of the constraints, and the times per unit of three products is 3, 1 and 1. So three products time per unit is 3, 1 and 1, and the right hand side is 500. So that means this is the newly introduced constraint which we have to add into the system. And since this is the daily capacity, so that's why obviously this constraint is less than equal to time. So in most of the questions we are directly given the mathematical form of the constraint to be added, but if it is not given, then definitely the information is given to us in the form of this kind of words or language. So we should be very carefully reading the statement and identify what is going to be the change. So here we have identified mathematically that this is going to be the constraint. So now we have got the constraint, so we need to know what to do next. Okay, so first thing we have to do is, in the constraint you substitute the optimal solution. See, always you are given the optimal table whenever you are doing any question of sensitivity analysis. So from the optimal table you read the optimal solution. So I can see that x1 is 0 because x1 is not in the basis, x2 is 100, x3 is 230. So if you substitute these values of x1, x2, x3 here, then in the left hand side you will be getting 330, and as per the constraint this should be less than equals to 500. So since 330 is less than equals to 500, therefore the constraint is redundant. That means it is already satisfied by the optimal solution. Hence, adding it into the system will not create any change. So this is the first possibility we can have whenever we are given any constraint, that you put the optimal solution directly into it. If it is already satisfied by the solution, that means no need to add it. The question finishes there only. It will not bring any change to the system's optimal solution. And then we need to discuss the case what happens if it is not satisfied. So to understand that, I'm giving you another example. So this time your constraint is this 3x1 plus 3x2 plus x3 less than equals to 500. And now if you substitute the optimal solution in this constraint, you get the left hand side is 530, which is actually greater than 500. It is not less than equal to, it is greater than 500. This means the above constraint is not satisfied by the optimal solution. Hence, addition of it into the system will definitely disturb feasibility. So we need to add it into the system and then get the new optimal solution, because this optimal solution is definitely not satisfying the constraint. So now we need to understand how to add this into the system. So we have done with the first step. The first step was whether to add the constraint into the system or not. So if it is already satisfied, no need to add. If it is not satisfied, then add. So next question we have to answer is how to add the constraint into the system. So since we know in the simplex table, each constraint first gets converted to equation form. So the same thing we have to do with this constraint. We have to convert this into the form of an equation. And since each row of the simplex table is representing a constraint, so when we add a new constraint, so that means one row is going to be inserted in the simplex table. And also, because with introduction of row in front of it, we will write a new basic variable. So a new basic variable is also going to be added. And since a new variable is introduced, its new column is also going to be inserted. So let's understand all these things with example. So as I've just told you, you convert first into equation form. So whatever type of constraint is either less than or greater than, when you will convert this into equation form, either you will be introducing a slack variable or you will be introducing a surplus variable. So but whatever new variable you introduce, you have the notation. So here already if you look at the optimal table, we already have variables up to 6. x4, x5, x6 are the 3 slack variables. So here I am giving the notation to the newly introduced variable x7. So this newly introduced variable will be the new basic variable. You'll come to know why this is so. So let's do the process in the table. So this is a table which is existing and given to us. Now I want to add the 4th row here because I want to add a new constraint. So and here will be the new variable added, and that new variable will also be coming here and its column will also be coming, because whatsoever is the number of variables in the LPP, each variable is having its own column. So this is going to be the change. This is a new basic variable, the slack which you have introduced, and this is the column of x7. Now since you look at the constraint, what you are adding, 3x1 plus 3x2 plus x3 plus x7 equals to 500. You have just seen that this is the constraint which we are going to add. 3, 3, 1 and coefficient of x7 is 1 and then it is 500. So same is here. This is 3, 3, 1. Coefficient of x7 is 1 and then 500. And since x4, x5, x6, they are not appearing anywhere in the newly added constraint, so their coefficients are 0 here. So that means in the newly inserted row, the entries are just going to be the respective coefficients. So in the column of x1 we'll be writing 3, in the column of x2 we'll be writing 3, in the column of x3 we'll be writing 1, and then in the column of x7 we'll be writing 1, and then right hand side is 500. And basis mein we add the variable x7. And obviously the column vector of x7 is 0, 0, 0, 0, 1 because it's coming only in the last constraint. So once we have filled the entries of the table, now you see that this table is not in correct simplex format, because see, x2 is in the basis, so the column of x2 should be 1, 0, 0 and it should be a 0 here, but actually it is 3. So the table has lost its simplex format. And similarly, the column of x3 should be 0, 1, 0, 0. So there should also be a 0, but this has also been changed. And column of x6, if you check, that is right, 0, 0, 1, 0, and fourth basic variable x7, its column is 0, 0, 0, 1. So that means you need to verify this condition after addition of a constraint like that the columns of basic variables should be identity. So whichever column is not identity, you have to make it into identity by doing the row operations. So x6 and x7, their columns are okay, but x2, x3 columns are not okay. This 3 needs to be made 0 and this 1 needs to be made 0. And so we already are familiar with row operations, how to make these two zeros. So doing that, you will get your new table. So this is the correct simplex table. Now this table is in correct simplex format. And now you think about what has happened. So now you look at the solution column, you are going to see a negative sign definitely in the right hand side. This is definitely going to happen because you have already checked that the constraint was not satisfied the optimal solution. Therefore, whenever you are going to add it and then converting the table to correct simplex format, you are definitely going to lose the feasibility. So you know what to do after that. Feasibility has been disturbed. Use dual simplex method to get the new optimal solution. So I'm leaving that part to you. You already know dual simplex method. So you do that and get the solution. This case you will be getting your optimal solution will be this and Z will be 1330. Okay, so earlier Z was 1350 but now Z is 1330. So this topic is also giving you an important result that this, if you read this note, that addition of a constraint always decreases the value of objective function for a maximization problem and it increases the value for a minimization problem. That means it always worsens the value of Z because more the number of restrictions, poor the best solution will be. So earlier it was 1350, now it is 1330. It has reduced. So that's just an additional observation. So you can finish your question here only after declaring the new optimal solution. So that finishes everything about addition of constraint. Yeah, sorry, we are left with one more case. Okay, equation type. What if the given constraint is an equality type? So if an equality type of constraint is given, so then we have to see what to deal with this. So the first step remains same. You put the solution in the constraint and see whether it is already satisfied or not. So if it is already satisfied, then no need to add. But if it is not satisfied, just like here, it's turning out to be 430 and definitely not equal to 600. So it's not satisfied. In that case, you break it into two parts, less than, equal to and greater than equal to. Then you identify out of these two, now you treat this question as two constraints. One constraint has been equivalently written as two constraints. So one of them will be satisfied and one of them will not be satisfied because the number 430 which you are getting is definitely going to be either less than 600 or greater than. So it's definitely going to satisfy one part of it. So here less than equal to type constraint is satisfied because 430 is less than 600, but this one is not satisfied. So therefore we will pick this one and add it into the system and the process continues exactly in a similar way, the way just I have explained. So with an equation type constraint, that's the additional step, that you do not directly add the constraint into the system with equality. You have to convert it into less than or greater than equal to type because we need to have a basic variable, we need to have a slack or surplus variable. So that's all about addition of constraint. In the next lecture, we'll look at another case of sensitivity analysis, addition of variable.